Hey everybody, welcome to PC Perspective. I am Ryan Shrout. We are here today with a special live stream with a friend of ours from AMD, newly minted at AMD again, I guess, Richard Huddy. Good to see you. Thanks for coming out.
Hey Ryan, thank you.
So we're here to basically talk about a bunch of stuff that is interesting in the news, product related, technology related. We're not here to launch a new product.
Indeed.
Right? But I think the world of PC gaming is going under a huge transformation.
Mm-hmm.
I think that's fair to say, both with new consoles coming out,
Yep.
increasing minimum performance levels, changing technology advantages that we have here, as well as things that change just from technologies you guys have, display technologies that have changing, 4K displays going out of this world, low prices as well. So we just wanted to kind of talk and see what the status of AMD is.
Okay, yep.
And you are...
A good time.
Yeah. I mean, you just rejoined the company. You are gaming scientist.
I am.
Please explain to me what that means.
Yeah, it's either the coolest or the geekiest job title on the planet, depending on how you look at the world. I'll go for cool. Because I'm really pleased with this opportunity. Gaming scientist is a responsibility inside AMD for moving information from ISVs, so lots and lots of conversations with the games developers who are working on high-end tech primarily. So there are many who will work on vanilla kind of tech, and that's not my responsibility. But if we're looking at the design of future GPUs to make sure that the hardware is designed with gaming front and center, this is now my responsibility to bring that information into AMD. And for that reason, I sit in the office of the CTO, which is a real treat. I get to work with some of the smart guys that you should maybe invite on for an interview. People like Roger, Joe Macri, Mark Papermaster, a whole bunch of super smart guys there.
Yeah.
And we make sure, like I say, 100%, this is a formalization of the process that guarantees that gaming remains front and center in AMD's GPU.
So this is a new position.
It is.
That is
Yep.
created.
Yep.
Okay. I think a lot of people, I know who you are, a lot of history with you, but give everybody else a little bit of a backstory about where you came from and how you got to this point.
Yeah, I started in 3D graphics in the 1740s or thereabouts, I think it was. It's been a long time. In hardware 3D, I joined 3D Labs in 1996 and was there for a couple of years to 98. That was consumer graphics time. There were folks out there like 3DFX that no one's ever heard of these days, setting extraordinary standards in real-time graphics. We were doing real-time consumer 3D graphics as well at 3D Labs. I went then to NVIDIA in 1998 and spent 4 years there up to summer of 2002 doing developer relations. So I started at 3D Labs doing driver work and discovered that drivers just never worked for DX because games developers didn't work with the driver companies enough. So I started doing developer relations, and then when I went to NVIDIA, it was specifically to do developer relations. I did that for 4 years. In 2002, I went to ATI, and in 2006, ATI was acquired by AMD. And up until 2011, I stayed with AMD. I then left for a little adventure in online poker. I was kind of expecting that the US was going to legalize online poker, and that was the big gamble. Given that they didn't, I decided to come back and get a proper job. So at that point, I went back to AMD. That was my first port of call. Times were pretty tough in the tech industry at that point, and AMD weren't able to take me back in. I looked around, and I ended up working for Intel. I spent about 2.5 years there, and in June this year, I've come back to AMD, and my primary reason is because of the things that AMD wants and believes in. Yeah, I love gaming. I want gaming to be the most important part of the technical side of my life, and that's not Intel's primary focus.
Right. So the kind of first question we had presented to us in our comment section on the news story was, what are you looking to achieve at AMD in the next couple of years? Now, that's a very wide open question, and we could probably talk for 3 hours about just that. But what would you say is the general consensus for what you want to achieve at AMD now in this kind of newly created position?
Okay, so it's probably worth taking a moment to say why I chose AMD rather than other prospective employers, because I looked around the industry, and actually the things which AMD are doing right now, things like Mantle and FreeSync, which are working through open standards, the work that they've done with OpenCL, constantly innovating, coming up with important new tech that changes the experience for games developers and games players alike. This kind of stuff is very, very important to me, and I want to keep that at the, like I say, front and center with AMD. So the opportunity to make this formally a part of AMD's reporting structure and the way we handle stuff is a big deal for me. And I guess sticking with open standards is my number one issue. It really matters to me a great deal that the work that we do encourages the development of the ecosystem of gaming, that games developers, that games players all benefit from this in a way that's much more general than just tying it to AMD. So that's my number one focus. And then really for me personally, it's about getting back into discrete graphics. I love the fact that we've done this 295X, this super high-end graphics card at the moment, which is very different from the work that I was doing at the most recent employer. And that's the stuff that I really want to get my teeth into, to look at this and see where the future lies for graphics.
Very cool. Now, it's interesting you mentioned the 295X too, because as it turns out, we have one of those to give away. We actually have 6 video cards we're going to give away on the live stream today. And I'm going to tell you right now how we're going to do that process. So we actually have 15, is that right? We have 15 Never Settle Forever codes that we're going to give away, in addition to 6 graphics cards. 260X, 270, 280, 280X, and a 295X too as well. Here's how you do it. I need you now, if you're on the live stream, to go to pcper.com/AMD live stream. And when you go there, you're going to have the chance to win one of these products. This here we have is the R7 260X card working there. And when you go to that webpage, though, you're going to be brought with a form that asks for your name and email address. And that's all it's going to ask you for. You submit it one time and you're entered in for the rest of the stream. We will then randomly pick a user that has submitted that form. Throughout, we're going to have multiple stops, 6 or so stops. Actually, I guess we'll have to do more than that with those Never Settle codes, and we will give away that hardware that way. So if you're watching this now, you need to go to pcper.com/AMD livestream and fill out that form right away. We'll come back in just a couple minutes and give away the first of many graphics cards, including a 295X2 with a 1500 watt power supply. So a quite reasonable upgrade, I think, for most people.
An awesome upgrade, yeah, absolutely.
Yeah. So we got a lot of topics we want to get to. Let's start in the world of API, right? You talked about one of the reasons you wanted to come back to AMD was because of Mantle. What is it that drew you to Mantle, right? So I'm also curious, you called it, you said AMD wants to stick with open standards. Do you consider Mantle an open standard?
Okay, very fair question. So Mantle right at the moment is written by AMD, specifically tuned for the GCN architecture, and that means it's not an open standard. Yep. But there are a couple of things which make it interesting for the future, and that's not just where we are today, it's because we have plans to take this further. Number one, although it's tuned for GCN architecture, we know that it will work reasonably well because it's written in as generic a way as possible for a DX style graphics card, that it would work on competitive hardware. Yeah, you could take a Mantle implementation for Intel hardware or for NVIDIA hardware, and you could generate something which is pretty efficient. Certainly, the super CPU efficiency of Mantle would be available on both of those platforms.
Right.
Now, at the moment, we're in a beta program. Yeah, we've got 47 registered active developers who are putting together Mantle software, and it's closed in the sense that this is invitation only, and the other IHVs can't participate. But AMD has made a public statement, a public commitment that we will put out an SDK this year, 2014, which will allow any IHV that wants to implement a Mantle driver. And that would mean that they would be able to take, say, the Battlefield 4 binary that runs on Mantle right now and shows advantages on AMD hardware, and they would be able to run it themselves. Yep, there'll be no license fee, there are no restrictions, we will not shut people out in any kind of a way whatsoever. But we need to own this as a standard because it's tuned for GCN. Yeah, if other vendors want to tune it for their own hardware and there are small tweaks where they want to get some small extra advantage, that's okay, they can do so. They can permute it as they like because the source code will be in their hands, but we're going to own the future of Mantle.
Gotcha.
Yep.
Makes sense. And it leads us to, realistically, I don't think we see that happening. I don't think you see Intel or NVIDIA really kind of implementing Mantle for their own hardware. because of the progression of DirectX 12. So in your mind, knowing that you know about DirectX 12 and its timeline, does Mantle continue to be an important resource for AMD after the release of DirectX 12?
Well, there's two parts to that. One is the decision of the other IHVs, and you're right, their pride may get in the way. They may say, you know what, low overhead APIs, they're the way of the future, but I refuse to accept AMD's leadership in this area. They may do that. It's their choice, and I would suggest that their customers should maybe put pressure on them if that is the decision they take. And hopefully they won't take that decision. The reason they shouldn't is that Mantle gives you the opportunity to exploit the hardware really, really optimally. If you see the CPU as a bottleneck, and this is typical in DX apps and GL apps, there are moments when the CPU is a bottleneck and it's typically just one core becomes the bottleneck.
Right.
Well, in that kind of situation, the owner of the graphics card, or the owner of the PC as a whole, is not getting the best gaming experience that they possibly could.
Okay.
And I would encourage the other vendors to look seriously upon Mantle. But you're right, DX12 is coming, and some of them may stand back and say, okay, it's all very well, but we'll ignore that, we'll wait for DX12. And there's a whole bunch of ways on the software side in which DX12 is very like Mantle. Mm-hmm. So we are seeing some software developers who are using Mantle as a kind of stepping stone to DX12. And for them, I think it's probably fair to say, for them, when DX12 arrives, they will perhaps shelve their Mantle efforts and focus on DX12. But for AMD, and for what I believe is a majority of games developers, actually Mantle has a healthy future. And it has a healthy future for two reasons, I think, that are easy to understand. One is that DX12 remains generic. Yeah, it works across all graphics cards, and it has, therefore, to expose capabilities which are shared between them and not exploit all the niche possibilities in some piece of hardware. And
right.
In our hardware, we can do better than that. We can give you more performance if we tune very specifically for our hardware. This is not a failing of Microsoft or DX. It's in the nature of a generic API.
Right.
So that's one reason why they would not. I suspect that for some developers who really push hard on the hardware, they will be able to get better performance out of Mantle, Mantle 2.0, Mantle 3.0, whatever we do in the future, than they can get out of DX12. Though there's no doubt that DX12 will narrow the gap. Okay, so it becomes a smaller advantage, I agree. But the other key point for AMD and for software developers is that Mantle is more than just DX. It's not DX11 only, it's not DX12 only. If, for example, AMD comes up with some cool new hardware feature, and in this kind of discussion I usually reach back to PRT, partially resident textures.
Okay.
When we invent it, it's pretty hard to expose it through DX. We can do GL extensions, but GL extensions aren't always terribly friendly to the kind of stuff that we want to do. And you have a lot of software architecture which is already there. It's kind of the baggage of the API, and it may get in the way of these new hardware features. We can expose those in Mantle. And we can expose those in Mantle not only in a way that is highly efficient, but we can do it the day the hardware feature arrives, which is really important.
Right.
If you think about DX11, it arrived in late 2009. And there have been two small updates to it, 11.1 and 11.2. But Microsoft's focus has not been so heavily on gaming since DX11 arrived. Those small updates are small updates, and they've
right.
come over what is it now? It's going to be a 6-year period by the time you get to 2015. That's a long lifetime for DX. Now, with our hardware, we will iterate more quickly than that, and we want to iterate more quickly than that. And so the opportunity is for us to own our own future, to put it in the hands of software developers who want to exploit it. Now, I said that a minority of games developers will use Mantle as a way of stepping to DX12. The bulk of Mantle developers, something I would guess about 2/3 of the developers that we have registered at the moment, are actually focused on what the tech can do for them that maybe DX cannot do.
Right.
And I think they will stay with us. We already have feedback from them that they don't want us to drop Mantle once DX12 arrives. They will stay with us. And if I take the 2/3 figure, then we're talking something like 30 developers or thereabouts. These are often big name developers who are pushing terribly hard. And I think it's very important to understand that these developers as a whole fall into two categories. You've got the folks like DICE, who are the leading developer on Mantle. They're the folks who brought us Battlefield 4 and who have a game engine which is an absolute tour de force of DX usage and Mantle usage.
Right.
Terrific piece of code. in my personal opinion, it's the best piece of code out there in a game engine at the moment. One day it'll be superseded, probably won't take too long. That's okay, that's great. We like that kind of competition. But it's a really spectacular piece of code. For people like that, pushing on Mantle, pushing on the very best you can get out of the hardware is a big focus. If you're a games developer at the opposite end of the spectrum, if you're doing something like Cut the Rope or Angry Birds, Mantle is just a waste of time as far as you're concerned. Yeah, for them, it serves no purpose. It doesn't solve a problem that they care about because they're not into high-end graphics and pushing the system in every possible way. But that's fair, yeah? You've got games developers who are about technology, you've got games developers who are about gameplay, and those who are about technology have obviously a good deal of focus on gameplay too. You can't just sell a game on the basis of its tech.
Right.
But for those who are focusing on tech, Mantle remains extremely attractive. We expect it to last, or the demand for it to last years, not 1 year or 6 months or something like that. It's a long-term investment.
Interesting. I have a couple more questions for you on Mantle. I want to first, though, I think we need to go ahead and give away our first product.
Yeah.
We need to make sure that we're getting these graphics cards in the hand of the gamers that really need them.
Absolutely.
So if you haven't already, go to pcper.com/AMD livestream. And what we'll have now is we're going to go ahead and have Alan, who's somewhere hiding in the background, draw a name. And he's going to pick it from that list. He's going to tell us who the winner is. So we're going to pick this winner now. We have 5 other video cards to give away, as well as some Never Settle Forever codes. And make sure you go to that and fill out that form. It's only asking for your name and email address, so it's really, really simple to do. So we'll go ahead and let Alan pick who that first winner is. And we're going to ship these anywhere in the world, so don't worry about that. We have capability to do that. We'll make sure you get the card and the code that you would need to win this video card. So we'll go ahead and let Alan get that in there for us so that I can see it in the doc, and then we will address into some other questions as well. Let me ask you this about Mantle. This was, again, a question submitted through our website. Do you think that Mantle-like APIs such as Metal and DX12 make porting of apps or games between different platforms easier than before? For example, is it easier to port from Mantle to Metal than from DirectX to OpenGL and vice versa? Or does it make things more complicated?
Interesting, and there's a whole spread of operating systems in there as well, which introduce their own complexities. There are a couple of things which are, I guess, really, really important in the software developer's mind. There are developers who work with a single graphics API. They're typically in the minority, in my experience. Most PC developers, for example, work with multiple graphics APIs. Whether that's Mantle or DX is actually not the kind of common simplest combination of APIs. Right. Typically, you find that people have an OpenGL driver or OpenGL layer. They have a DX layer. They may have a layer for PlayStation 4, for Xbox One. They may have one for a tablet, an OpenGL-ES layer, something like that. It's usually the case that there are multiple graphics APIs which are supported when a games developer is doing their work. As a result of which, adding another graphics API tends not to be a large amount of work. Now, for the guys at DICE who did this when they were shipping a game, it may have taken them, I'd speculate, something like 4 or 5 man-months of effort to do all of the work, which is quite a lot.
Yeah.
It's a significant effort, especially if you take the quality of the engineering that they're throwing at this.
Sure.
But remember that they're working with an incredibly unstable software setup at the time. We're busy trying to build our Mantle driver, and that's not going to be the funnest experience in the world.
Right.
These days, I think it's fair to say we have a driver which is release candidate, so it's pretty stable, pretty solid. And I would say that a games developer can typically invest somewhere between 4 and 8 man-weeks or programmer weeks of effort producing a Mantle implementation, and then it just sits and works. And it's no harder to do one of these somewhat lower level APIs than it is to go up to DX or to OpenGL. So I don't think that it complicates the task very much. It's one extra API, but for some, the fact that it's one API may actually give them portability, which helps them a lot. So the advantage of Mantle is that it's very console-like. It doesn't solve any technical problems for us to consider taking Mantle to one of the consoles, to the PS4 or the Xbox One. It doesn't solve any technical problems. that portability is already pretty good. That's the point of Mantle, to give people an API which is very like those consoles.
Right.
If you want to take other AMD platforms, so AMD hardware is present in more than just the PC and more than just those consoles, then you can think about Mantle coming to those platforms, and maybe that would be a more portable way of taking your code from PC to that platform. And I know Linux has come up as one of the operating systems that's discussed there.
Right. Very interesting. The winner, by the way, of our R7 260X was Paul Hervé. So congratulations, Paul. We will email you after the stream sometime later today to talk to you about getting your shipping address and all of that. Meanwhile, Alan is over here setting up and getting the next 2 graphics cards we're going to give away, which they're the ones at the back of the list there, the back 2 there. And yeah, we'll give away those. So we'll have them set up here. This is what's coming up next, guys. We have a pair of Radeon R9 270s. This is the MSI and the HIS 270 graphics card. So we have that going for us. So stay tuned for that. We're going to give that away. Again, pcper.com/AMD livestream is the place for that.
It's a shame we weren't able to see Alan there, because he's in a gorgeous spangly swimsuit, and if the camera would just catch him.
Yeah, that's true. That's true. Let's see. I think our discussion of Mantle is interesting. You brought up HSA. What does Mantle give for HSA, positive or negative? Can you talk to that any? It's more of an APU focused thing, but what does Mantle bring to that? Is it just, again, kind of making these types of ports easier?
So the primary focus of Mantle this time around has been has been getting the CPU out of the way of the GPU. In situations where a single core is a bottleneck in DX or OpenGL, then we try and resolve that problem, and Mantle is primarily about, therefore, revealing the extra performance in the graphics hardware in those situations. In future iterations, we will absolutely expose the goodness that's in HSA. So there is a very close interconnectedness between the GPU and the CPU, which collectively make the APU. And current APIs, DX and OpenGL, do not exploit that interconnectedness. They don't typically allow you to, because they are generic, they don't allow you to treat the 2 pieces of memory as if they were one in circumstances where that's true. And that means that you sometimes find yourself moving memory from one place to another, in spite of the fact that the hardware doesn't actually need to. Well, we can obviously expose that in Mantle too. We can take advantage of the fact that there is no copy needed in those situations, that there is virtualization that allows the CPU and the GPU to share addresses in some cases. All that will be exposed in future iterations of Mantle, and it will become a big deal in Mantle, yeah, no doubt.
Interesting. We had all kinds of interesting questions come in here. We've talked about Mantle for a while now. There was a very controversial thing that happened over the last month or so in the graphics world. And this kind of centered around GameWorks, which is an NVIDIA program. It's an NVIDIA library of software that they license to developers to use in their games for visual effects or things like that. So we wrote about it on pcper.com. We talked about it quite a bit. I'm curious, after some of the dust has settled on all that, where do you stand on that now? Like, what is the kind of AMD view or your view on what GameWorks is and what it attempts to do and why it's interesting to AMD?
Well, yeah, it's... There's still some dust settling on this one. I think it's by no means final. So if I take you back in history and show a few examples of things that have gone on, we can kind of set the scene and then look at what's happened with GameWorks. It is the case that on AMD's website, for example, you can download cool effects from our SDK, the software development kit. You can take things like TressFX, which is a hair simulator, and I don't know why people are interested in hair. I don't know. I don't get it. For me, it doesn't seem that important.
I can see, yeah.
Yeah. But we have effects like this, which we put out into the public domain in effect. Although there are sometimes IP issues with simply putting the code out there and saying you can do anything you like with it, we do actually put the code out there, and we actively encourage games developers and the other IHVs, if they wish, to look at that code and to play with that code, to develop it and to make it better. Yeah, because our claim is never that we've got the best code there is and that it can't be improved upon. TressFX is an interesting example. We published the source code, and it was then used in the Tomb Raider game to improve the quality of Lara Croft's hair. Now, importantly, we did it in that order. We released the source code, the game came out, and the game uses TressFX, but we supplied the source code to the games developer. Throughout the process, we supplied the source code, because if a games developer is going to ship a game, they need the source code. For example, Epic. Typically, you get the full source code for the engine. Certainly these days, at $20 a month for all the engine, you take the full source code. You don't take a whole bunch of DLLs and hope that you can link things together in some cracking new way and build a game without knowing really what's going on. You don't do that. You work from source. Microsoft's SDK supplied in source. Sony's SDK supplied in source. Intel's SDK, supplied in source. Qualcomm's SDK, supplied in source. Apple, am I getting repetitive? Apple's SDK, supplied in source. NVIDIA's SDK, supplied in source. Except all of a sudden, GameWorks is not. GameWorks is supplied as a DLL. And it turns out that if you look at what's going on in some iterations of those DLL, you see some code which is highly inefficient on AMD hardware. Now, if it happened just once or twice, you could say that's just carelessness or someone not trying to optimize. There is, for example, to contrast GameWorks with what we're doing with TressFX, there is TressFX 2.0, and it has been aggressively optimized by AMD for Intel and NVIDIA hardware. And if they choose, of course, the source code's out there. Yeah, clearly we're putting it out there because we believe that games developers will use it in the future,
right,
and they can optimize for their own implementations too. The source code is not restricted in its accessibility to any of the people in this ecosystem. But that's not what NVIDIA are doing. NVIDIA have changed from the way their samples used to ship, and now they're putting out these DLLs which happen to be very inefficient on AMD hardware. Now, you could say, okay, inefficient on AMD hardware, efficient on NVIDIA hardware. Yeah, important phrase. Inefficient on AMD hardware, efficient on NVIDIA hardware. Well, that's NVIDIA's choice, isn't it? And the games developer can choose it as well. Here's an interesting point, though. Say the cape in Batman, which uses GameWorks, is heavily, heavily tessellated, way more tessellated than it needs to be. And that means that it's actually inefficient on NVIDIA hardware as well as inefficient on AMD hardware. Now, it's more inefficient on AMD hardware. And if you're the vendor, well, I'm from AMD, so I can see my resentment boiling when this sort of stuff happens. But if you're the vendor and you're NVIDIA, what on earth are you doing? Why are you producing code which is deliberately chosen, I guess, because they produce this DLL, to be inefficient even on their own hardware? I speculate, and I'm not a mind reader, I cannot guarantee that my interpretation is right, but I speculate that they do it because the impact, the negative impact on AMD hardware is better, yeah, for them. And that's a sorry state of affairs. They are not deliberately giving the best experience that they could. And it would be straightforward if the source code was shipped to the games developer, that the games developer could change it. But the games developer can't change it.
So the TressFX example is interesting because when Tomb Raider originally shipped, TressFX was essentially broken on NVIDIA graphics cards. They had issues where her hair didn't show up at all, or you saw eyeballs instead of a skull, and it was very odd graphical issues there. And NVIDIA kind of said the same thing, where they would say, you know, we didn't really know about this software, this tech, before the game came out. And now it is public. They've been able to fix it. They've been able to improve performance in that particular way. So why is it different from that, right? Now that GameWorks is out there and they are licensing code to developers now, why can't you just kind of go in and now you guys can fix it now, right?
Okay.
Can't you do the same kind of thing that we've seen for years and years in the past?
Yeah, there's a lot of assumptions in there which are worth going over. So if we replay the video and make sure we go back through each of the parts
Okay.
of that, it would be good, because I don't want to miss any of these. There are things like, can't you go over and do shader substitution, the kind of stuff which is done in drivers? No, because these DLLs change late in the day on us. Yeah, we've seen cases where we had a 6,000 line shader where we're supposed to do shader substitution or late shader optimization, a 6,000 line shader, and it changes in the last or second to last build which is given to us, and it's only available in a DLL. Yeah, so we have to work completely blind. We can see none of the algorithm. We can't see any of the high-level optimizations which would be available. We're deliberately being restricted by the DLL policy that they're applying here to stop us getting at the code. I contrast that with what went on with TressFX. With TressFX, we supplied source code to the developer. We supplied source code to the sample on our website, and we did that before the game shipped. And because the source code is supplied to the developer, and I guarantee you there is no contract between AMD that I have ever been involved in, ever seen, or ever heard about that restricts the distribution of that source code to other IHVs, other vendors like NVIDIA. That means that NVIDIA could, if they were involved with the developer, go in there and optimize it. And they can say, wait a minute, this code doesn't work here, fix this, fix that. Yeah, they can raise these issues because it's in source code form. And they can actually say, look, this source code is inefficient on our hardware. How about changing it this way? Have you thought about this algorithm? They can do all of that because we gave access to the source code to the games developer. Mm-hmm. That's the opposite of what NVIDIA are doing at the moment. By shipping DLLs, and that was up until April this year, DLLs only, no matter what you ask for. Yeah, games developers never ask for DLLs. I have never been asked for a DLL to be put into a game. DLLs for parts of the tool chain, I can understand that, like a texture compressor. You just want to build that into your tool chain, away you go. But in the game, you need to be able to debug it for other people's pieces of hardware. And they were not doing that up until April, and they've relented on their policy. They will now ship source code to some games developers, but those games developers are not permitted to share it with us. And I have emails from ISVs which say, I can't work with you on this. NVIDIA's contract forbids me from sharing. Now,
sharing the source code to GameWorks.
Both sharing the source code and actually saying, you can't work on this. We're forbidden from optimizing this code with AMD. That's what the contract says according to the ISV. Now, I can't bring that email out. I regret to say, because that conversation is under NDA between the ISV and us. And if the ISV gets named, then well, another company will go up to them and say, look, you're not supposed to talk about this contract. So the ISV is timid about it, but it's a wretched situation, and it could be fixed. And I'll give you two ways of fixing it. Sorry about this, I know you're going to come in with a question. It could be fixed. One is just distribute the source code. If NVIDIA distributed the source code to GameWorks, to the developer, and said to the developer, optimize this as you see fit. It's your game, you ship it. Mm-hmm. Then they could choose to share it with us or not. You know, if a games developer wants not to share it for any reason, that's okay, it's their choice.
Right.
If NVIDIA don't get involved with the development of Tomb Raider and don't optimize it, that's okay, it's their choice. Yeah. Each of the companies should have a free choice here, but it should be a free choice. One way to fix it, NVIDIA, just publish the source code. Yeah. Make it available for each of these DLLs when you share a DLL with an ISV. That's a fair way of making sure that the algorithm can actually be looked at and implemented fairly on all pieces of hardware.
Okay.
But here's another way of approaching it, and here's something that we're talking about inside AMD at the moment, because this is a wretched kind of situation and the power is not in the hands of the ISV, the independent software vendor. So what we're thinking about is putting our SDK out and giving it to an ISV community and letting them develop it as a kind of open source initiative, and we will make something like OpenFX or OpenWorks, whatever you want to call it. Right. We're talking about this at the moment. We will make that a public domain repository for code, and we will give all of the IP that we own in that SDK, give it to this repository, and it will be a bit like a Linux community where people can go in there and they can improve it. They can improve it for NVIDIA hardware, they can improve it for AMD hardware, because we don't always produce perfect implementation. Right. And they can port it to other platforms as well. That's a way of taking the ecosystem forwards instead of backwards. That's a way of making sure every games player gets the best experience.
Interesting. I have some more questions on this, but first I want to go ahead and announce we have the winners of our Radeon 270 graphics card sitting here. We've got the MSI as well as HIS. And if you haven't entered yet, it's pcper.com/AMD livestream. You can see that there on your screen. You go there, fill out the form, and you'll be entered in for our next giveaways, not this one, because we have the winners of these two cards. The MSI 270 goes to Alan Jacobson, and the HIS 270 goes to Mark Waters, otherwise known as Hethris or Hethris on PCPer. So congratulations to you guys. Coming up next, we will have a Radeon R9 280, of which I'm working on a review of that particular graphics card right now. And then we have a 280X and a 295X2 still yet to come to give away during our live stream.
Beautiful.
So I want to get back to this. I want to ask you, now that NVIDIA has offered up the source code to GameWorks, explain to me again, why is that still not accomplishing the goal that you think it should? They've told me that they have released source code for everything, every part of GameWorks that will run on AMD hardware. So like PhysX won't ever run on AMD hardware, so they don't need to provide the source code for that. So why is it still not enough? Is it the contractual issues that you were referring to?
Yeah, rather sadly, I haven't seen any of that source code, and nor has anyone in my ISV team. And when we ask for it, we're not given access. So if NVIDIA would publish it on their website and say, this is the latest iteration, and it's fair for them to improve upon it, if they publish it there, that'd be cool with me. Yeah, so they could have the DLL, they could have the source code, you can build the DLL out of the source, you can tune it as you like, that'd be great. But what they're doing at the moment, as far as I can understand it, is they're shipping the source code to some software developers under restricted circumstances, and again, they are contractually binding that ISV not to share the code with us. Yeah, they are not allowed to share it. This is what we're hearing. The email that I referred to earlier on has come in since April. Yeah, it is still the case that software developers are being forbidden from sharing this code with us. Now, if NVIDIA would make a public statement that that's not true and they release anyone who thinks that they're bound, I'd love to hear that. Yeah. I suspect they won't make such a statement. They'll make some bland statement that they would never do such a thing, and then they'll carry on doing it. That, I regret, is my suspicion.
Yeah, the problem for us, for both gamers that are kind of innocent bystanders in any of this kind of bickering or fighting, and even us in the media, is that we can talk with you guys and you can tell us your side of the story. No, they will, everybody will say that we're not doing that. They have access to the source code. Yes, they may not want you to see the source code, but if the developer has access to it, they have the capability to tune and tweak for that. I'm more curious, so one of the justifications for the existence of GameWorks that NVIDIA gives is that it's not just code samples. It is essentially a middleware application now, right? Where they're trying to address the problem of they could create all these cool code ideas and these examples of things, but they would not ever be implemented, or would very rarely be implemented. And so by providing it in an API-based middleware package, they're able to accelerate adoption of some of these technologies. If that's the case, do all other middleware companies kind of supply source code as well, or do they do it in that black box DLL format?
It's a rarity to work in this black box DLL format. The Epic engine is currently available in full source. It's easy to get hold of the source, and that's the natural way to build an engine and to tune an engine, to develop it from the kind of very first build that you try and make. You need to start working on the source code and changing that source code. There are middleware vendors who restrict access to the source code, but I know of no case where something like this, which affects the performance of one hardware vendor, is in the hands of another. What happens is this kind of egregious situation can arise, and I'll lay out that egregious situation. It's now possible, and NVIDIA can say whether they do this or not, but it's now possible for them to create code which is shipped to the game's developer late in the development process in a black box format in this DLL. It can be contractually required as part of a GameWorks contract that it will be in the game, so the game developer can't take it out no matter what they think about it.
Right.
And the code arrives for us on day one the game is released Maybe we see it a week beforehand, maybe we see it a month beforehand if we're really lucky. But I remind you, these DLLs change, so our last-minute optimization opportunities are, boy oh boy, they're last minute. Yeah. This code is then shipped in the game, and on day one, NVIDIA can put out a driver that optimizes that code because, heck, they wrote it. They know that, if you take a 6,000 line piece of code like the hair in Call of Duty Ghosts, the fur on the dog is roughly a 6,000 line shader, if I remember this rightly. It's mighty hard to optimize that in an efficient way when you have no access to source code. NVIDIA, of course, have full access to the source code. They can do any optimization they like. They could even optimize a lot of it out if it turned out not to be necessary, if they found a more efficient implementation. On day one, AMD will be running code that NVIDIA wrote that NVIDIA themselves do not run. That doesn't seem like a great way to benchmark, and the truth is, games hardware, GPUs particularly, is very often benchmarked by those games. And if you take a day one game, you've just got this new game and coming out, and you're saying, okay, I want to see which is the best, NVIDIA hardware or AMD hardware, the possibility that AMD will lose a benchmark because it runs code that NVIDIA wrote that NVIDIA does not run, that's an extraordinary possibility to be facing. And I'm not saying that's what always happens, but it's a wretched possibility to be facing.
Is it fair to say that this is a worry of AMD's of possibilities, not something that you have necessarily seen take place yet? Like Watch Dogs release was a GameWorks title. It was kind of the instigator of this discussion again, even though I think the only GameWorks implementations that they had were actually NVIDIA only, right? It was just like, here is an example of a game that's using it, which opens up these ideas of these possibilities. Is that still, this is a potential problem rather than a currently standing problem, or you guys have other games that this is happening in?
There are two things here. One, I point out the possibility that we may find ourselves running a benchmark which the competition wrote and which they don't run. That one's kind of hypothetical, but it shows just how wretched this situation is and why AMD is alarmed about it. That's one side of this. The other one is things like over-tessellation. So the cape in Batman is a thing of beauty, yeah? But it does not need millions upon millions of triangles in order to render itself well. And the observation that it's heavily over-tessellated on both pieces of hardware means that you come to the conclusion, if you benchmark it, that actually that over-tessellation is a performance cost for everyone who's playing on NVIDIA hardware and AMD hardware that they should not be facing. It isn't an efficient piece of API programming, and other examples like that exist, which worry me a great deal about the motivation here. If you go back to Crysis 2, there's this famous example of the water, which is hugely tessellated. Even when it's not visible, the tessellator is doing this huge amount of work, and it's slowing everyone's hardware down, but it's slowing AMD's hardware down more, and that's why someone has kept it in. That's the kind of conclusion I'm pointing at, and that's a rotten place to be. Yeah, let's work with source code. Let's work with source code.
Okay. So now you guys have Mantle, and some people would say that, hey, this is AMD creating an API that totally blocks NVIDIA out. Like we talked about the idea of open versus not open now. Today it's closed. You guys are investing in an API that will improve performance for only your hardware. But you can't hurt NVIDIA's hardware performance? Is that kind of the argument you make there then?
Yeah, this is an important distinction. NVIDIA have, by sticking with DLLs and by making it hard for us impossible in fact, to get access to the source code, they've created a situation where they can harm us and harm us in benchmarks, and that's unhealthy. There is nothing that Mantle can do that can harm NVIDIA. Yeah? If a games developer chooses to work with Mantle, then they will also do a DX11 version of their code. They may choose to do an OpenGL version, etc. They can go to any other API. We have not, in any situation I'm aware of, ever tried to restrict an ISV from, say, doing Mantle plus other APIs. So we don't have the possibility of doing any harm. There's no possibility that any malicious intent at AMD through Mantle can result in harm to NVIDIA. Regrettably, I can show you that simple kind of argument that I've just been through, that it is now possible for NVIDIA to cause us harm in benchmarks, and that's not a healthy place to be. Moreover, Mantle really will be an open standard. It is possible that by the end of 2014, AMD won't have opened it up, the SDK won't be published. It's possible. Someone might fall under a bus the day they're about to publish it, but our commitment is that we will put it out there. It will be a standard which is open if people wish to implement it. There is no cost. Yeah, NVIDIA are tying people in with with really very unfortunate terms in the contract. And please, if you're serious about what you're saying, NVIDIA, then just say, we'll put out the source code, we'll allow games developers to share it with AMD, and we won't bind any ISVs whatsoever. We are clearly in that position, yeah? The Mantle 1.0 spec that will come out this year, anyone can implement it. And interestingly, if you look at our hardware, that is to say PC graphics hardware, there's a lot that's in common there. You know, we implement the DX11 spec, and we do it these days in AMD. We do it through GCN architecture. It's a wide scalar architecture. The instructions are scalar. They run in 64 or 32 or 16 parallel pixels. Very, very similar to what's actually going on inside NVIDIA hardware. I'm clear in my own mind that they could, if they chose, implement a Mantle driver, yeah, that would actually work really well and which would gain them efficiency on the DX11 apps that they're only running on DX11 at the moment. I fully understand that there's politics involved and they may choose not to for all sorts of perfectly valid business reasons. It's their decision, but we are not trying to shut anyone out.
Is there validity to an argument that supporting too many APIs spreads resources too thin, right? So NVIDIA, you know, as this Mantle push came from AMD, NVIDIA focused on, hey, look at what we've done to improve optimization for DX11 drivers. And the claim has always been, look, if AMD is spending all this time on Mantle, they're obviously sacrificing resources they could be putting into DirectX 11 development, right? Which is just, you know, despite the push that Mantle has, it's still obviously the drastic majority of gaming titles. Yep. So in your mind, do you see the resources of AMD being spread too thin by having to focus on, well, you've got to make sure DirectX 12 is working, and you've got to focus that DirectX 11 is running optimally, and now you've got Mantle, right? Do you worry about not having the man hours necessary to keep everything up and running at its optimal performance level?
Well, every company has finite resources. So from a kind of logical perspective, you're right that there is a limit to what we can achieve. If we put all of our resources onto a single API, then we would be able to do a better job. However, realistically, we have had DX11 since 2009. Yeah, for 5 years, we've been optimizing our DX11 driver. And it's been about 3 years since we started the conversations with ISVs about Mantle. So I guess I've been outside AMD during that period, so I can't give the exact time frame. I'd guess something like 18 months or so of effort has gone into the Mantle driver. But we've put in more than 5 years of effort with a large software team on getting our DX11 driver optimal, and we produce great performance there. There is no reduction in our commitment to the DX11 driver. Yeah, we have finite resources. I admit that there are engineers that move from one to another, but there's also a great deal of expertise that's shared. When we do, here's an interesting result, yeah, which is beneficial. If you think that splitting the effort across APIs is problematic for a company, then bear in mind that Mantle led the way for DX12, yeah? We showed that the programming difficulties inside APIs can be dealt with in a way that actually Microsoft had really struggled with in the iterations of DX10 and DX11. I remember standing up with Microsoft on stage and saying DX10 will have better throughput than DX9, and DX11 will have better throughput than DX10. Absolutely the focus, yeah? This was not something that was deliberately broken or anything like that. People put a huge amount of software engineering effort into getting DX10 better than DX9, DX11 better than, et cetera, et cetera. Right. And the effort that we have put into Mantle, the commitment that we've made to give software developers and games players the best experience, has helped inform DX12. We have been working on DX12 all the way through the Mantle effort. We have shared the information with what we've done with Microsoft. This goes back to the point I make about improving the ecosystem. Making things better for everyone is the way to pull this industry forwards into the future, not into the past. And the stuff that we've done with Mantle has very definitely positively influenced DX12. I think the proof, it's kind of an existence proof that you can produce a driver which is so much more efficient than DX11. I used to joke when I was out with ISVs that there were ISVs, there's IHVs, and there's Microsoft. And if you get any two of that three into a room, they'll always blame the other one for what's gone wrong. And a bit like Superman and Clark Kent, for some reason you can never get all three in the room and have the same discussion. Yeah, you just can't do it. So when we sat down 3.5 years ago, when I started, for example, the conversation with DICE about Mantle, and I didn't have that code name at that point, it was a matter of we've tried really, really hard with Microsoft working on those APIs, but we believe that there is goodness in the hardware that is not being exposed. Are you willing to spend some time, to invest the time with us, to give more to games players? And the answer from DICE was an enthusiastic yes. They believed that they could differentiate their games from existing tech. They could make it better. So we've spent that effort, and we have not tied it all into Mantle and said, oh no, we're not letting anyone else take advantage of this tech. We've improved the ecosystem as a result of it, and we've changed the way the industry works. You go back to September 2013, there are no low-level APIs. Yeah, there aren't any. In October, we introduced Mantle. In March this year, Microsoft made the announcements about DX12, and we were working with them on the driver work that they're doing, along with other IHVs. And since then, we've also seen Metal come from Apple. People understand that low-level APIs are actually part of what needs to be done, and it's to a significant extent because AMD has led the way. Yeah, we've gone out there, we've invested heavily in API work.
Sure.
So I think it'd be fairly harsh to say, couldn't AMD do a bit more with DX11? DX12, I think we deserve some credit for driving the industry in the right direction, for showing the very clear way that things could be better.
All right. We are going to break here for a second and give away this R9 280 graphics card sitting here. This is from Sapphire, and Alan has been kind enough to pick a winner for us. This is Adam Wells. I feel like I've said that name before. I feel like you've won something on our streams before. Congratulations, Adam Wells. You win a Sapphire R9 280. And we have other prizes to give away. We have a 280X from MSI, and we have a Radeon R9 295X2 with a 1500. It comes with the 1500 watt power supply still to give away. And of course, we have 15 Never Settle Forever codes, which we will give out, but we probably will not name every name that wins all of those, just for being a little bit more concise. So we'll go ahead and switch over to the 280X there, and let's.
Can I just say, Alan's the lucky winner of the 280 there. But if you're not lucky enough to win, you guys are doing a review, so you'll be able to make your own judgments about whether.
Yes, we have a review of a 280 coming up probably next week. So awesome. We'll see how that combines. It won't be this specific one. The one you get will be brand new. I won't have tested it and benchmarked it. I don't think. I don't know. I guess I won't promise anything.
Test it and sign it.
I'll burn it in for you. Yeah. I want to ask you some other questions, maybe a little bit off topic. Well, not off topic, but off of that topic. Let's talk about platforms, something like SteamOS. Where is AMD's stance on Linux gaming support, SteamOS in general, commitment to that? Like I said, we're talking about spreading resources thin, and now we're talking about a whole other operating system to deal with as well.
Yep. So AMD's commitment is really clear. If this is the future of gaming, then absolutely we will support it. And what we're seeing at the moment is that there's a lot of enthusiasm for the Steambox. Valve have their own good reasons for deciding to go down what is a pretty unusual route for a software developer. Most folks don't produce their own kind of console PC. But there's AMD design out there that you can pick up for a Steambox. And our commitment is sufficient to all of this that not only will we supply a high-quality OpenGL driver, but we're also considering, emphasis on the word considering, this is not a commitment or a decision, for example, taking Mantle there too. We want to give the opportunity for the games player to get the best out of the hardware. And if games developers say, we think we can do better than just using the standard API, OpenGL, DX, whatever it might be, can we have Mantle, please? Then we will listen to that. So no doubt at all. AMD is fully committed to gamers wherever they may be.
What do you think about the kind of reliance that PC gamers have on Microsoft and Windows? You kind of already mentioned it. We talked about DirectX 12. Is it something where AMD saw Microsoft kind of dragging their feet with DX12, took the first step with Mantle to kind of force everybody to come along? The question in there was what do you think about gaming on other than Windows, right? And not just consoles.
Sure. So I think my PR manager would be less than thrilled if I were to describe Microsoft as dragging their feet. And I think the truth is that it's something different from that going on as well. Microsoft have a big business to run, and they have their own decisions to make. And there will be times when they see leadership in gaming and graphics as the number one priority, and there'll be times when they have other things as their number one priority. With Windows 8 and 8.1, they I would suggest they made decisions to focus on the big change that was coming with tablets versus PC, that kind of stuff. So I understand that graphics is not always going to be the number one priority with Microsoft. It's fair and reasonable for that company to make their own decisions, and indeed all of the others. And that's why Mantle is a big deal for us, because it gives us the opportunity to hold our future in our own hands. We can take Mantle to other platforms. And one of the things to understand about AMD is that we design our GPUs, at present at least, with one piece of IP in mind. The GCN architecture is what we will take whenever we take a new GPU into a new environment. So yeah, we look at places which are not Windows based. We look at Linux. We look at the consoles which have shipped with GCN style architectures too. And for AMD, the future is very much not PC only. And that's not just about Windows, but it's not even PC only. Lisa Su made a statement at the Computex press conference that we had 2 or 3 weeks back, where she showed quite an interesting trend in AMD's business. If you go back, I think it's a couple of years, something like 15% of the turnover of AMD comes from non-PC business. So 85% is heavily reliant on PC. Right now, it's about 35, if I remember the numbers right. 35% of our business is not based on the PC, the traditional PC. And by the end of 2015, again, if I get the numbers right, it's supposed to be about 50-50. Yeah? And that means that the opportunity to take that one core piece of IP, yeah, this intellectual property, which is the most superb, the most efficient, the tremendously flexible graphics core next that we have, and take it into other environments. That's a very interesting place for AMD. Yeah, we will push that out into other places, and the portability of OpenGL or Mantle or whatever, that's always a great place to be. We understand that the visual experience, the gaming experience, is a really big deal for AMD.
Interesting. Now I'm going to ask you about G-Sync, Adaptive Sync, and FreeSync. Before I do that, though, I do want to mention one more time, people on the live stream, the URL to go to win free stuff is pcper.com/AMD livestream. Next up on the block is the MSI 280X that we have sitting right here. You can win that graphics card. And in addition, we're going to go ahead and have Alan draw the rest of the Never Settle Forever code winners here in just a little bit as well.
We're still not getting a glance of Alan in his spangly swimsuit, are we?
No, I really wanted to keep it off the stream.
Yeah?
We wanted to keep viewers, though.
Okay, all right.
Yeah, and I'm going to turn it off.
Okay.
So we'll do that, and then we will end, of course, in the grand finale of the 295X2 and the 1500 watt power supply. So we're getting into some stuff that happened definitely before your return back to the company. But I want to talk about G-Sync and what you guys have kind of jokingly called FreeSync, and then what has become Adaptive Sync in the world of the DisplayPort, the VISA consortium or whatever. What is the comparison of G-Sync to Adaptive Sync or FreeSync, whatever you want to call it, and what are those differences between them? Right? I have seen G-Sync in person. We have G-Sync monitors. We've used them. I saw a demo at CES, but that's all I've really seen of kind of the open implementation of it. So what am I to expect, and what are the differences? Okay,
so these are all ways of addressing the same problem, trying to get rid of tearing, particularly in a gaming environment where you have a variable frequency, where the frames are generated, some of them very fast, some of them really a lot slower, where there might be as much as a factor of 5 or so in the kind of frame rates that the game is showing. It's not uncommon for that. So they're all trying to get rid of tearing. G-Sync is currently a proprietary solution from NVIDIA, and I don't know whether they're opening the standard up. But there is a hardware cost associated with it, and there's a licensing cost associated with it. What we're seeing at present is typically an extra cost to the consumer of around $125 to $150. That's an adder to the cost on the monitor. But it solves the problem of tearing. Yeah. So you've got to say, getting rid of tearing is a good thing.
Yes.
One of the interesting things about embedded DisplayPort, which is actually built into a large number of the displays in things like the
notebooks,
the notebook that you have in front of you, is that those already have a significant amount of capability that's effectively that described by G-Sync. They have the ability to set different refresh rates, for example, for power saving. So maybe you switch from 60 hertz down to 30 hertz or 25 hertz or something like that. And they have the ability also to switch down to a different frequency for something like video playback, maybe 24 hertz, because that's the frequency of the video, and that way you don't get beating between the 60 hertz and 24 hertz. Included in the embedded DisplayPort is this idea of the variable frequency as well. And it too is there for primarily power saving reasons.
Right.
Okay, so if we get to FreeSync, FreeSync takes that basic kind of capability and exposes it now in a VESA standard, which is straightforwardly added to the DisplayPort spec. So I think it's 1.3a, maybe someone will correct me.
I think it's 1.2a.
1.2a, yeah. Okay, I'll take the correction. And what it does is it allows the monitor to say to the graphics card, hey, the maximum frequency I can cope with new frames is, say, 240. That happens to be the top end of the spec. And the minimum is, say, 9 hertz. That's the bottom end of the spec. Now, a monitor doesn't have to declare the whole range. It can say, I can cope with 30 to 70 hertz, which is actually probably the sweet kind of range for gaming. Or maybe it can pick 40 to 60. And the demo that you saw at CES, sorry, not CES, if you saw it at Computex, was running on a monitor which is available in the market at the moment and which was upgraded through a BIOS update. So it was actually declaring a range of 40 to 60 hertz. And if the game happens to run with all its frames generated in that 40 to 60 hertz frequency range, then no frame will ever tear, which is a great thing. Yep, we like that. And interestingly, that's a monitor that's already in the market, that's being updated through a BIOS update, which means that there is no extra hardware cost. Yeah, it's zero. And AMD put in the spec to VESA. VESA adopted it, so there's no license cost as well. Yeah, G-Sync, $125 to $150 more. FreeSync, $0 to $0 more. Yeah, it's as good as that.
Right.
But right now, you're right, you can get a G-Sync monitor and you can't get a FreeSync monitor. Our expectation is that you, Ryan, will probably be lucky enough to be able to get a FreeSync monitor around September or October. That's when the prototypes will come from the various vendors who are working on these units. And then from early in 2015, something like January or February, the first ones will arrive in the marketplace. Okay. And as I say, I want to emphasize, the frequency range which the monitor supports depends on the vendor's choice. But our graphics cards, things like the 290 and the 260, which support FreeSync right now, will interrogate the card. They'll say, okay, I understand, I hear you about your frequency range, and then they will fix within that frequency range. So you can imagine that monitor vendors will say, okay, I've got a FreeSync monitor, and they'll just maybe put that out there a little blandly. FreeSync, by the way, is not the marketing name that will arrive. I don't know what people will call it, but FreeSync's probably not great from a consumer point of view. You don't want to put that on a box. But the monitor vendors will be able to choose the range that they support. So they may well go for something fairly vanilla in the first place, this kind of FreeSync, and they won't be very explicit about the range. But those people who want to produce a high quality monitor, let's say a 4K monitor that goes really all the way down to 9 and all the way up to 240 hertz, they ought to be able to charge a premium, yeah? Because actually they'll be buying a panel which has response rates of up to 240 hertz, which is very quick. So I can imagine that there will be a price differential between the highest quality FreeSync monitors and the initial relatively low frequency band, but that's okay. You pays your money and you takes your choice. It's the way the world is.
Right. Yeah, it's an interesting thing to discuss, right? Because I think in some ways you have to give NVIDIA, if you guys get the credit for Mantle for pushing ahead and kind of forcing everybody to see low level, NVIDIA's G-Sync was really kind of the first instance of somebody saying, hey, we can take this, it is a pre-existing technology, right? But they said we can apply that to gaming and fix a fundamental problem that has been in not just PC gaming, but all kinds of display rate, rate matching issues for years and years and years. But I am curious to see kind of what the quality difference is, like what the experience difference is. Will the free version of it in the DisplayPort standard really kind of do the same thing?
It should actually do the same thing and be better. I'm bragging again, aren't I? So one of the advantages of FreeSync is that the monitor, when you plug it in, it's a plug and play moment. The monitor says, I can cope with this as a maximum, this as a minimum, and then it's up to the GPU to work with it. And as I said, the 290 series and the 260 series, they already support all of that kind of infrastructure. So all we need to do is ship a driver when the time comes. But because the monitor does this, there is no negotiation between the monitor and the graphics card from moment to moment. G-Sync has a buffer in there. It has a 768 megabyte buffer in there because the monitor doesn't talk to the graphics card in the same kind of way, and they don't negotiate a maximum and minimum frequency at plug and play time. So the extra unit that you plug into the monitor, which copes with G-Sync, that's capable of buffering up an extra frame. And an extra frame means an extra frame of latency as well. So you get the smoothness, but you get latency. There will be more lag associated with G-Sync if it operates by storing a frame. So I think it's fair to say that in the main, the quality will not be that different. There is an extra frame of latency, and for games which are running fairly slowly, you'll feel the extra frame of latency. Yeah, I mean, we see this in games at the moment. If you're running at 20 or 30 frames a second, it's a bit painful. The latency hurts.
The one advantage that G-Sync seems to have is it will work with all of their GPUs. Whereas it has come out since, basically around Computex timeframe, that only the 260X, the 290, the 290X will support FreeSync. What is there, I mean, again, this is maybe getting too technical for this specific discussion, but why is that, and is that something you guys can change? Is that a problem with the product that will have to be adjusted in the next generation, or?
So all of our future product will support the FreeSync spec. What we have here is there's a certain extra complexity in the display controller, which we didn't choose to put into to everything. So it's in the 290 series and the 260 series, but all our future GPUs will support this, and our APUs already support, and all those future ones will support it. Now, when the monitors come to market, January, February, that means that anything that you buy that's new, you're almost certainly going to be getting the stuff that matches the monitor. But I didn't want to hide this stuff. Yeah, there is a difference. Not our whole current product range supports FreeSync. But the and I've been clear about which parts do.
All right, let's. I guess we got the winner of our MSI 280X announced here. That is Philip Gallas. I'm probably mispronouncing that. Galas. Philip, you are the winner of this MSI 280X graphics card, and we'll ask a few more questions here. We'll get into some of the future technology stuff. We'll have Alan in his bathing suit switch out the graphics card one last time. I think you guys will be really impressed about this new one. We've got some Never Settle Forever codes to give out, and of course the 295X2. If you haven't already, feel free to go to pcpro.com/AMD livestream, fill out that form, and you will be entered in for our contest when we are getting to the end of it. If you've already entered once, you don't have to enter again. You're automatically being included in that random.org selection of parts. So there you go. That is a 1500 watt Intermax power supply with a Radeon R9 295X2. That's a $1,500 video card, and I think that's like a $400 or $500 power supply.
It's a fairly significant chunk of hardware.
It really is.
I think it's the fastest video card on the planet at the moment, isn't it?
I think it is.
Okay.
I think it is. Based on my own independent testing. So we've talked about a lot of specific products, specific topics. I want to get into maybe a little bit of out there stuff, future technologies. One question came in, with things changing as quickly as they are right now for gaming, what technologies or advancements are you most looking forward to?
Okay, yeah, nice open question.
Very
where
open-ended.
I can go anywhere I like. One of the most obvious changes is 4K monitors. These are coming up on us real fast, and I noticed one of the questions in the forum was, when are we going to deliver a graphics card that will deliver really smooth kind of 60 hertz game on a 4K monitor consistently? Well, we will produce such a thing. At the moment, you probably need something like that, 295, if you're going to go there. But 4K gaming is a big difference, and rather sadly, it's not the end of the story. If you look at what the human eye is capable of, the resolution of the human eye over the full field of view is about 8K. If you have an 8K monitor that fills your field of view, then that's about the resolution of the human eye. So I can imagine that we will need to go not just to 4K, but to something like 8K or maybe 16K to allow people with good eyesight, make sure you're past the Nyquist limit for eyesight. Then you will have kind of perfect pixels everywhere. Everything will look super smooth.
Sounds good so far.
It's an awful lot of pixels, and it's an awful lot of horsepower, which means that we need to do a couple of things. We need to continue this amazing process that I've had the pleasure of watching over the last 15 or 20 years of building faster and faster GPUs that just have phenomenal amounts of compute power in them. I remember when I went to SIGGRAPH in 1992 the very first time, and I saw $1 million box, which was about the size of this table. And it was the Reality Engine from SGI, phenomenal thing, and it could do what a year 2000 graphics card could do, and it was $1 million box. We certainly need to keep on this process. So I think that the next 5 or 10 years of the improvements in compute density in GPUs, that's a fairly safe bet. We will continue to go that way. But one of the problems that we have with GPU design is that memory just doesn't keep up. And a number of the vendors in this market are already talking about the fact that in the future we'll have to go even faster than GDDR3. And there are a number of solutions which we're looking at there. People are talking about GDDR4 and stack memory and things like that. And the ability to give ourselves access to mammoth amounts of bandwidth in future is really important, because although we can build a GPU with incredible compute density, in the end you need to get that compute on and off the chip at super speed.
It's always been a problem with GPU design, is a memory interface that can provide the GPU with enough compute power.
Yeah, you see us trying different memory design after, all these memory interfaces change from a couple of years to a couple of years as we refine the designs that we have and look for new ways. And on top of that, we will actually use physically different memory. So things, as I mentioned, like the other memory types. That'll be a big deal. And then I think that if you take an engine like Battlefield 4, which is superbly optimized, whether it's DX or OpenGL or Mantle, whatever it might be, superbly optimized engine like that, and continue to throw the compute power that we're doing into this pot for games developers to work with, and give them the bandwidth improvements that they need, then you will end up with a situation where they'll be able to render something which is indistinguishable from reality. And when you have an 8K monitor or a 16K monitor, oh well, okay, so we sorry, you're going to have to throw your monitors away for another couple of generations yet. When you have that kind of stuff, then you really will be able to produce something as a games developer which is indistinguishable from reality. And that's a lovely place to be. One of the surprises about 4K monitors is that it actually requires more from the games developer than just doubling stuff up in terms of pixels. They don't just have to double up their texture resolutions and maybe improve the quality of their geometric meshes. You actually need to throw more detail in. The developers who just let the scene kind of expand in terms of pixel count don't tend to fill in enough in the background to keep reality as real as it should be. And I was talking to one of the guys on my ISV team recently, and he's making the point that Mantle actually allows you to throw in more detail because it's taking out the brakes when it comes to CPUs. Then the CPUs become more available for throwing more detail into the scene, and you get richer scenes with these higher quality monitors, and I expect that to continue into the future. And that means that the ISV teams that we have who are out there working with games developers, my good friend Kevin Strange, who's a huge fan of yours, has a livelihood ahead of him of several years still working with games developers to do more. Yeah, pushing them to throw in more reality. But we can get to something which is indistinguishable from reality around the year 2020. Pretty close to that. Yeah.
I plan on still being here doing this at that time, so
I
that would be,
hope so. Yeah,
that'd be a plus. All right, I want to go ahead and announce our never settle forever code winners. So I'm just going to name off some names. These first 10 people all won silver codes. And I will send you an email sometime tomorrow probably to send you that code. Josh Nicholas, Kevin Spring, Milan Maximovic, Dimitar T. I'm not even going to try that one. John Wallace, Robert Kizilewski, Flo Galong, Maxim Ren, Stefan Haas, and Roberto Rodriguez. They all won silver codes, and now gold codes. Never settle forever gold codes, which are worth, correct me, right? Three games, right? 3 games. Henry Mueller, Petrosor Alexandru, Mike Green, Kit, just single name, and Kaskaran as well. You guys all won Never Settle Forever game codes, courtesy of AMD, and we will email that to you as well. And don't forget, we do have one more prize to give away. The Radeon R9 295X2 and 1500 watt power supply sitting right there. I'm going to go with $2,000 or so worth of computer hardware. So we will. That will be the grand finale. We have a couple more questions here. We've been getting some questions in from the chat as well. This one I think is relevant since we just gave away those Never Settle codes. How do you guys pick which games are chosen for Never Settle? Is that something that like you approach developers about? Do they approach you about?
So we have a developer relations group that works very close engagements on the titles which are coming up over the next year or two. So we focus the bulk of our attention on the games which are coming up in that kind of a time frame, and we also look for interesting developments into the future. And yeah, absolutely, we want a portfolio of games that we can use for marketing to exemplify the use of AMD hardware. So we look at games which have a good history. We look at games which benchmark well, that they are reproducible.
Sure.
So reproducible benchmarks are very valuable. If you have to go in there and benchmark it 50 times before you really know what the performance is, it's a problem.
I know exactly.
We positively encourage games developers to put in benchmark modes so that you can record your own benchmark, so that we cannot steer you too much in one direction or another. We think it's healthy that you guys should be in charge of owning the decision about how to benchmark. And we look for IP which is very successful in the marketplace. So it's no big surprise to see us working with games that have long established histories. That Tomb Raider's a classic example. 15 years ago that game first came out, and there we were working with it for TressFX. We look for matches between the technology and with the game, and there are times when we look for games which are very suitable for bundling in all sorts of territories. So one of the issues that we have geographically is that, for example, Germany has a register. It will only allow certain games in, and some games which are too bloodthirsty will not be allowed. And when our AIB partners or OEMs are looking at bundling, sometimes they'd say, can I have a nice, safe racing game instead of something which is a bit too bloodthirsty?
Right.
So we have all sorts of considerations there. But we have a really active team that are working with pretty much all of the AAA, I would say every single one of the AAA games developers who are out there on the PC area. And we're looking for interesting new pieces of tech all the time, interesting new stuff, and looking for opportunities to give the game visibility and give our hardware visibility.
Very cool.
Very diverse.
The Lude asks, since graphics are getting to a point where it's already fairly realistic, although as you pointed out, we have a lot of room we can go with that, when are other improvements in gameplay, specifically AI, going to be improved drastically? This is not necessarily a graphics-related question, but more of like kind of an industry-related, non-gaming technology, or non-rendering technology.
So one of the really cool things about the GPUs at the moment is that they're much more flexible than you might expect. You'd think that if you built a graphics chip, it was essentially only capable of doing graphics. But it's probably a decade or more ago that people realized that the compute can be used for other things. And it turns out, very interestingly, on this specific question, that most AI problem solvers are actually limited by line of sight tests. There's a huge amount of interrogations of the database which are basically, can this person see that person? Can this thing see that thing? It's the single commonest part, and actually that works really well on a GPU. You can give the GPU the database of the terrain, the various visibility criteria,
right.
and you can ask the GPU to figure it out, and it does a stonking job of doing that in parallel. So we're already seeing that some games developers are moving things like the AI onto the compute engines that we supply in GPUs, and there is to be fair, it's a fairly slow process while games developers move the code which typically ran on a very serial single core of a CPU,
Right.
and they gradually propagate it to multiple cores on the CPU, and then eventually onto the GPU. And things like OpenCL, that standard programming language which lets you get at the compute horsepower of the GPU, that's a perfect way of solving AI problems, and certainly of solving a lot of the detail of the AI problem, even if you let the CPU get at it later on.
I think this is a good one. What, if anything, have you learned from your other ventures or your other previous stints at other companies, Intel, ATI, NVIDIA, that you think improve what you can bring back to AMD today?
So nothing to do with online poker, huh?
No, no. I mean, hey, if online poker has a drastic impact on what you're bringing back to AMD,
No.
maybe the ability to gamble some more, like taking chances.
Actually, I think one of the things that I learnt, I don't know, there's a whole selection of stuff. Be dynamic. Number one, own your own future is number one. Be proactive. Go after things. If you believe in something, then chase it aggressively. And that's why I'm talking publicly about being enthusiastic about things like OpenFX or OpenWorks. If you believe in stuff, go for it, and commit yourself to it very aggressively. One of the surprises that I learnt when I was at Intel, I used to think when I was at AMD back in, say, 2006, 7, 8, I used to think Intel want us dead. Completely wrong. Really surprised by that. So not only because of the monopoly concern that Intel would
Right.
immediately have if AMD were to go out of business as a CPU company, but actually that isn't their view at all. They're very happy with the business that they run, and they want to expand into things like tablet. They made public statements about wanting to sell 40 million SoCs in 2014. It's clear that they've got other markets that they're playing in. But one of the things I really learnt there is that this industry is not best conducted as headbutting between two competitors, AMD versus Intel, AMD versus Intel. That's not really where life is. And certainly for AMD, we see 50% of our business going forwards outside the PC space. That's just by end of 2015. Be diverse. Look into other opportunities of exploiting the IP. I was really surprised to discover that Intel's actually, in a sense, a nicer company than I thought it was. I thought they just wanted us dead, but they didn't. And sometimes, every now and then, I think, okay, maybe my mind reading about NVIDIA is wrong. Maybe they're not that bad. Maybe they're not doing this maliciously. But I do worry about GameWorks, I have to say. It keeps reminding me that just maybe.
All right, we're going to announce the winner of our R9 295X2 and Intermax 1500 watt power supply. I don't have a drum roll sound effect.
should
I'm sorry.
have a drum roll.
I'm sorry. I have no. And it's Ryan Shroud, everybody. It's amazing. It's staying here. We're gonna. Oh no. Okay. Somebody says that's not right. Okay. The winner is Ray Pattison.
Congratulations,
Pattison. You have won a 1500 watt power supply and a Radeon R9 295X2 courtesy of our friends at AMD. So the final question came from the chat room. Which teams make it to the World Cup final and who wins?
Which teams make it to the World Cup final? England beats Hungary 6-0.
Okay, all right. I'm going USA over Germany 2-1.
In the final?
Oh yeah,
USA
sure.
over Germany?
Yeah, sure. I mean, that's
It could be. It could be.
at least both of my teams are in it.
Okay. Yeah.
So at least I got a better shot at that.
Hungary quite unlikely winners, I think, this time around. Yeah, it's true.
Well, thank you very much for stopping by. It was very informative. I hope everybody watching enjoyed it as well.
Right, it's a great pleasure, and AMD would love to come back in future. I know we've been a little bit hesitant about taking up these opportunities, but we would love to be back here. So yes, please.
Although it's locked most of the time, we have a totally open door policy for vendors that want to come in and talk about their products and talk to the readers and really come out and answer questions, because we want to have that open dialogue, right?
Yeah.
I think it's best for everybody.
I'm sure you guys will have follow-up questions from this, and we'd be more than happy to
Absolutely.
do it.
I'm looking at the questions that Scott gathered for us in the page, and we just didn't have time to get to all of them. But some are good, and we'll talk about them maybe later this afternoon and see what we can get out of it as well. Maybe do a written follow-up.
Absolutely.
As well.
Be happy to contribute to that. Brian, thank you. Yeah.
Of course. So thank you guys for joining us. If you are new to the PC Per live streams, you should definitely make sure you take note of coming back, pcpro.com/live. We do live events all the time. We actually have a live podcast recording tomorrow evening as well, 10 p.m. Eastern, 7 p.m. Pacific. If you go to pcpro.com/subscribe, you can sign up for a little mailing list there, and all we do is we send you emails when we do live events like this as well. And sometimes they come with free stuff that we give away, so it'd be kind of silly not to sign up for it at this point. So thank you everybody for joining us. If you showed up late to the live stream, we will have this posted on our YouTube channel probably sometime later tonight as well. So thanks guys. Talk to you soon.
Thank you.